For my final project, I chose to make a biomass gasifier stove. This is a picture of the final product, and I can take you through how I made it. So this was my original plan for the 3 different parts of the stove that I made. Just kind of zoom in on each one. This was the large baked beans can that I used. 6 large holes at the bottom to provide the airflow. I have some screws drawn in there, but when we were looking at the cans we decided to modify that a little bit, so there are no screw holes in the can. The medium interior can was just a Campbell's tomato soup can. 10 holes around the bottom that are about 3/16 of an inch. 16 holes around the top that are 1/16 inch each, and then I used that 1/16 inch drill bit to perforate the bottom of the can as well. And then the third can ended up being a small can of chopped clams. It worked really well because it fit really snugly on the top of both the baked beans can and the medium tomato soup can. And I wanted to have something that was a pot holder on the top with a large hole for feeding the fuel into the inner cans, and so I really like that design, and this can worked well for doing that. So we were able to use a 1/2 inch drill bit to drill holes around that, and then we used some tin snips to cut away a couple of those holes to make the feed hole. The bottom cut was the hardest cut that we had to kind of make just because we weren't sure what we were going to do. Peter ended up finding a 2.5 inch drill bit in his things, so we were able to cut that away. Okay, so once we knew what design we were going to use for the stove, the first problem that we tackled was getting the bottom cut out of the center of the clam can. And what Peter started out by doing was attaching the can to a couple of pieces of wood so that we were able to clamp it down to the drill press, and then he used a 2.5 inch bit to drill out the bottom of the can. Next, we moved on to cutting the Campbell's Soup tomato can, which is the inner can. We started out by making 10 holes along the bottom edge. They were 3/16 inch holes. You can ignore the measurements that are on the can. Those were my initial ideas, and then we went with what drill bits we were able to find in the basement. After we did the bottom ring of holes, we moved to the top and did 16 holes around the top that were 1/16 inch holes. And then we flipped the can over, and on the bottom, we just perforated the bottom with a lot of 1/16 inch holes down there as well. While I was working on drilling the holes, Peter took a pair of tin snips and just cut a couple of slices through the bottom of the clam can so that the edges would flare out when we pushed the soup can through there. And he also took a larger drill bit and just tried to clean some of the burrs off of the can as I was done cutting them. The last can that we worked on was the large baked beans can, and I drilled 6 holes in the bottom of it that were 5/16 inch. These are the vent holes that'll draw the air in from the bottom to pull the gases through to burn. The last cuts that we made were drilling holes into the clam can at the top for venting right underneath the pot, and we used a 1/2 inch drill bit on that. And then we used tin snips to cut an opening in the side for a feed hole for the fuel. final step in building the can was taking the clam can and pushing it down onto the soup can in the middle. I wanted to create a tight seal at the top just so that the air was being pulled up from the bottom rather than coming in from the top. So this is the final product that we made. You can see the bottom of the can here, and then this is the inner part. This on the inside here is where the fuel will go. And then the top is going to be the pot stand, and then this is the hole that we cut out so that we can feed additional fuel into the fire when we start it. You can see it fits real snugly on the top there, so there's no air coming through the top of the can, just down here at the bottom. Alright, so these are some pictures from our first test burn. I did this back at my parents' farm with my brother's help. We used some pine twigs down at the bottom and then put in some pine bark as well as some pine needles for the kindling to get it started. We got a nice flame going, and in the last picture here you can see the jets of fire coming out at the top.
Yes. Yeah, solar power battery can. Yes. Then it's hot.
Are you gonna bring your thing? Your panels?
Oh, see, it's reburning. Do you see the little jets of flame coming out there? And they're blue. That means it's burning the gases on the inside.
So it's done?
It's starting.
After that first test burn, I was concerned that we weren't getting enough oxygen into the center can because we were having trouble keeping the fuel lit. So I went through and drilled an extra row of holes in the middle can and also an extra set of holes in the outer can. So for the test burn, my daughter and I gathered leaves and twigs as well as some dry kindling that we had in the garage and some dryer lint. We wanted to use things that I thought we would typically have on a camping trip. We packed it in real tight into the inner canister and then just used matches to get it started. Okay. So this is at almost 4 minutes. Got a pretty good flame going. Don't quite see the jets yet, so we're going to keep blowing on it. We did see evidence of gasification as we were getting the stove ready. However, we had a real hard time keeping the fuel lit on the inside. We'd get some nice hot coals and we'd add some more fuel into it, but it almost was as if it wasn't getting enough oxygen from the bottom to stay lit. We put the pot on at about 6 minutes and 15 seconds. It's at about 7 minutes now. We did put a layer of aluminum foil on the outside of the pot just to protect it from the flame marks, and we think that may have had an effect on how much heat was transferred between the flame and the pot. We're at 10 minutes. So we ended up putting the cover on the pot, so we're having trouble keeping it lit. We're at 28 minutes. Here's how it's looking. Having trouble keeping the flame. We stopped the test at about 40 minutes. We had just had multiple problems keeping the fuel lit. Did use a thermometer to check the temperature, and the water in the pot made it to about 135 degrees. For comparison purposes, we took our backpacking stove, which runs on white gas, and we used the same pot and the same amount of water and timed how long it would take to get up to the same temperature as the backpacking stove that I made and how long it took to get to a full boil. It took about 2.5 minutes for the white gas stove to get the water to about 135 degrees Fahrenheit and about 3 minutes for it to get to a full boil. So just some final thoughts about me creating my biomass gasifier stove. I had a lot of fun with this project. It was a lot of fun planning how I was going to make it, as well as creating it with the help of my husband. I had a great time talking about it as well. I was able to share my ideas with my family and my girls, and we had a really good time just thinking about how it was going to work. As far as cost goes, really the only cost that I had was buying the baked beans for the outer can, significantly less than the cost of buying the backpacking stove that we did so many years ago, as well as the environmental and ongoing costs of purchasing the fuel for it. Going forward, what I would do is possibly add more holes down here at the bottom to increase the airflow, as well as possibly adding some more holes down here or using mesh down at the bottom to increase the amount of air that is able to keep that fire burning on the inside. The other thought that I had was a lot of the videos used a more consistent fuel, such as wood pellets. As I mentioned before, I didn't want to do that because I wanted to see how it would work with the fuel that we would possibly find when we were backpacking. Like I said, I had a great time with this project, and my girls mentioned even if it didn't work for backpacking, we could always use it for toasting marshmallows in the backyard. Thanks so much.